Hey everyone, it's me, Miss B, and today's video we are looking at homework number 19. This is a review for the Unit 2 test number 2. So we're going to do our best to justify all of our thinking as we answer each question. So justifying our responses here and to show our work in order to earn full credit, the same way you would have to do on the test itself. So with that, let's get started. So for number one here, we have parts A and B, and we are going to solve without graphing, meaning we're going to use substitution or elimination, and then identify which method would be better first, then solve and check. So already I can kind of tell you which ones of these would be better for substitution or better for elimination. If you look at this one here on the left, you'll see that everything is kind of aligned. I have my x terms, addition or multiplication, my y terms, the equal sign, and then constants. Things that are aligned like this generally work better for elimination because you have to have them aligned in order to eliminate. But over on this one, I have something here in slope-intercept form at the top, and then I have something in standard form here at the bottom. So if I wanted to have these aligned, these do not go together. One of these is y, and the other one is 2x. And I definitely don't have my equal signs lined up either. So this one would work better for substitution. So those are both of the methods I'm going to show you. And we'll start here with elimination. Oops, that is not an M. I keep giving it one too many. There we go. This is going to be elimination. And then for this one, we'll use substitution. Okay. So for elimination, we want to either add or subtract these. We might have to multiply by something, but the goal is for one of our variables to cancel the other one out. Now, I know that the book addresses this as subtraction when they give you two terms that are exactly the same. They want you to subtract them from each other. But sometimes I think that's a little hard to keep track of in my head, and I would rather just use whichever signs are in front of me and not have to worry about, am I subtracting this negative or am I subtracting this positive, and which way does that go? So I'm going to do this as addition, except I am going to multiply everything here on the bottom by -1. And the result of that is that everything gets multiplied by a negative, meaning everything's sign changes. And now I can just concentrate on piece at a time. This is 3x minus 2x. This is -7y plus 7y. And it makes things a little easier. So we do know that because we set this up to eliminate, -7y and +7y will eliminate, but 3x minus 2x just gives us 1x or x. And then over here on the right, with the -2 and -1, this is just like -2 minus 1. It's going to become even more negative, and we'll get -3. From there, we don't actually have to divide by anything because there's no coefficient on x. So we're able to plug it right back in. I'm going to plug this into one of my equations to start out with. So I'll just use the 3x minus 7y equals -2. And we'll plug in, instead of x, we'll plug in the -3. So 3 times -3 minus 7y equals -2. This is -9. Minus 7y is -2. That means we want to add 9 to both sides in order to make those disappear. We'll still have -7y. Be careful about negative signs. They do need to still stick around. And over here on the right, we're going to have +7. So next step, which is our last step, is to divide by -7 on both sides. And this creates y equals -1. So the answer to this one is -3, -1. That is our complete answer to this question. And that is the elimination method. Now, the other method is substitution, and that works very nicely when we have one variable all by itself set equal to something else. So this is solved for. That means when I have something solved for a single variable, I am going to be able to take whatever it's equal to, I'm going to stick parentheses around it and say, okay, wherever I can see this y in my next equation, which is right here, I'm going to put 3x minus 11 instead. So we get to rewrite this as 2x minus 3, but instead of y, we have that stuff in the parentheses, and it's still going to equal 5. So the substitution here, that's the 3x minus 11. And now what happens is this entire equation only has x in it. There's no y's, and I'm able to solve for x. So let's do that. I'm going to take -3 and distribute this -3 across. So 2x minus 9y, and then -3 times -11 is plus 33 is equal to 5. Oh, I said minus 9y. If you're like, Miss B, what are you doing? I thought you just said that was x. It's absolutely x, and I just had a brain fart. So now we have 2x minus 9x. So 2 minus 9 will give us -7. So this will be -7x plus 33 equals 5. We're just combining these two. Let's subtract 33 from both sides. Then that will be -7x equals -28. And then our last step will be to divide both of these by -7. That will leave us with x equals positive 4 because it's -28 divided by -7. From here, the easiest thing to do is going to be bringing this back up to the top and plugging it into the y equals equation. So I'm going to bring this back over and plug this into y equals 3x minus 11. So this will be y equals 3 times 4 minus 11. 3 times 4 is 12, and 12 minus 11 is 1. So this answer is 4, 1. And that is the substitution method. Now, C and D are going to be a little bit different and perhaps different versions of this. So let's go through those, and I won't explain in detail as much for every single one here now that you can see what our different methods are. For question C over here, I'm going to use substitution because I can see I have x all by itself and it's equal to y minus 9. So that means wherever I have x, I'm going to plug in the stuff that was in these parentheses. So we'll have 5 times y minus 9 plus 3y equals 11. This becomes 5y minus 45 plus 3y equals 11. Combine the 5 and the 3y, so that's 8y minus 45 equals 11. And then we're going to add 45 to both sides. So when we do that, you'll get 8y is equal to 56. Now, I know that 8 times 7 is 56. So what that means is that when I divide both sides here by 8, 7 is what's going to be left over. Now I can take that back, plug it in to x equals y minus 9. So x is equal to 7 minus 9, and that's going to be negative 2. So overall, our whole answer is negative 2 comma 7, because we always need to do x and then y. And that's our answer. For part D, we have some choices here, but I think the easiest way to do this one is going to be with elimination. So I'm going to show elimination. I was doing that mostly in red, so I'll do that in red. Ooh. Okay. Now I'm going to do that. I have to multiply something here in order to make this work. I'm going to multiply this top one by negative 3. So this whole thing, we're going to multiply by negative 3, and we'll write that over here to the side. So I'll get negative 3x minus 6y equals negative 15. And then this one will kind of just stay the same. Positive 3x plus 7y equals positive 13. And then we're going to add these two together because now I have something set up to eliminate, and that is the x terms. Negative 3x and positive 3x will eliminate. Negative 6y and positive 7y, so if I do negative 6 plus 7, we'll get 1y. And then negative 15 plus 13 is going to give me negative 2. So this will give us y equals negative 2. I'm going to go back and plug that into x plus 2y equals 5, mostly because those numbers are pretty easy. They're smaller numbers and none of them are negative, so it seems nicer to plug in. So this will now be x plus 2 times negative 2 is 5. So this is x minus 4, or plus a negative 4, which means we're going to add 4 to both sides, and that x is going to equal 9. The answer here is 9 comma negative 2. And those are the 4 questions from question 1. So the 4 parts of question 1. Now, for question 2 here, it says solve by graphing by hand and not using Desmos, because you will not be able to use Desmos on this test. So practicing with Desmos is not going to make this any easier. So I'm going to graph this first line in red, and then the second one here in blue, and then to solve by graphing, we find the intersection. So negative 3 over 2x plus 1, that means my slope is negative 3 over 2, and my intercept is 0 comma positive 1. So we're going to find 0 comma 1 right here, and then we're going to go down 3 and to the right 2. So down 3 and right 2 puts us down here. We're going to keep following that pattern. We can also follow it up and to the left and show our line here. So let me draw this line. Nice to do with a ruler, but honestly, the slope is probably the best tool to use in order to get your straight line. So always a good idea to like actually mark and label where it hits corners on your graph. So hopefully both of our answers will end up touching corners, and that's where our solution will be. So this next one though is not in slope intercept form yet. So it's going to be a little difficult to graph. You could, because this is in standard form, you could use the cover-up method for this. So if I was to do that, I would maybe make something to block out my number to obscure it from my view so that I can cover it up and say, okay, if I'm plugging in 0, the x-intercept should be 4. And then here, if I cover up x, negative y is 4, so divide by negative 1, and you should get the x-intercept, or the y-intercept is negative 4. But I'm going to show you how to do this using slope-intercept form as well, since some of us are more comfortable with that. So that's really just solving for y, which means I'm going to subtract x from both sides just to start. Be careful though, because it does leave you with negative y. And then I'm going to put x first, because we're used to putting variables first, and it is mx plus b, not b plus mx. So it's going to be more comfortable for our brains that way too. So negative x plus 4. Then you have to divide everything here by negative 1, or multiply everything by negative 1, because this is really like a negative 1y. So this will be positive y, and positive x, and a positive 4. Oops, no, I'm sorry, not positive 4. Wow, it just said that was going to make it easier. It's a negative 4, and we did just say that our y-intercept should be negative 4. So now we're going to graph that one, and it has a slope of 1, which means it's going to go up 1 over 1, and we said our intercept is 0, negative 4. So let's find that point, 0, negative 4, and we're going to go up 1 over 1. Oh, it does land on one of those common corners. We can also follow it down and to the left. I'm just going to draw my line straight through here, but making the points the important part. So now, this part right here where they intersect, this is the important part. This is the x value of positive 2 and the y value of negative 2. So that is the solution, 2 comma negative 2. And so practicing graphing without Desmos, I'm not happy with that answer box there. There we go. That's better. So yeah, practicing with graphing. You should not be using Desmos for this, but you can definitely use it to check yourself. Though I do recommend using this video, which you're watching, obviously, if you're hearing me say this, or asking your teacher for sure. So let's move on then to the back page, or the next page. There are actually 3 pages to this. So it's 1 page front and back, and then another side on an additional sheet of paper. Okay, so for question 3, we have 2 different types of things here. I'm sorry, we have 2 different sets of equations here. And they're asking us on this one, is 3 comma negative 4 a solution to each of these systems? And we do not need to actually solve the system in order to answer or explain this. All we need to do is actually plug these numbers in for x and for y. So let's do that for this first one here. So 2x minus 5y equals 26. We want to know 2 times 3 minus 5 times negative 4. Is that equal to 26? And we also want to know is 3 minus, now this is where things can be tricky because it's minus y. So it's like a negative 1y, so it's minus negative 4. Is that equal to negative 1? And it needs to be true for both. Maybe I should have done that in a different color, but that's okay. Let's work this one out on the left. 2 times 3 is going to give us 6, and negative 5 times negative 4 is going to give us positive 20. Is that equal to 26? Yes, 26 equals 26. So it works for that one, but it needs to work for both. So now we need to actually figure out, is it going to work for the second equation here? So really this is just 3, and then minus negative 4 is really like plus positive 4. So is 3 plus 4 going to equal negative 1? No, 7 is what it's equal to, and that's not negative 1. So the answer here is no. In order to be yes, it has to be yes for both. No, it only needs to be no for one. So if one's yes and one's no, just like this one, the answer overall is no. let's do the next set here. So 3 comma -4, I'll do this one in blue. Now, this one can be tricky if you start trying to plug things in order because here we have y, and that is not our first number. Our first number is always x, 3 comma -4. So -4 is what we're going to plug in first. Is that equal to 2 times 3 minus 10? And then for the 3x plus 2y, this is now in the right order. So 3 times 3 plus 2 times -4 equals 1. So we want to test both of these. So let's start with the one on the left. -4 is just -4. There's nothing to multiply it with. 2 times 3 is going to be 6. So 6 minus 10. Is -4 equal to 6 minus 10? Yes, if you do 6 minus 10, you do get -4. So that first one checks out. We need to make sure the one on the right checks out also in order for it to be a solution. So 3 times 3 gives 9. And then 2 times -4 makes -8. So now we have 9 minus 8. Is that equal to 1? Yes. So 1 is equal to 1. That checks out. So since it's true for both, we can say yes. True for both. Okay. Question 4, we have a word problem. So there's a theater that sells 2 types of tickets, evening and matinee. Evening tickets cost $25 each, and matinee tickets cost $18. On one Saturday, between the 2 types of tickets, the theater sold 250 tickets and made $5,424. We want to write a system of equations representing the 2 constraints. Constraints are just the situations. That's the situations we have going on. So let's write 2 different equations. Let's write an equation based on the number of tickets first. So I know the cost of each. I'm actually going to define my variables here first. I'm going to say that E is number of evening tickets. Now, I can't just say that E equals evening tickets. I want to be specific, whether it's the amount of them or the cost. So that's why I'm saying it's the number of evening tickets. And then I'm going to say that M is equal to the number of matinee tickets. Okay, so now if we're writing a system of equations, we're going to write one based on the amount of tickets and one based on the amount of money. So if it's just the amount of tickets, that equation would be like evening plus matinee. And since these are both amounts of tickets, this is equal to 250 because they sold 250 altogether. Now, if I'm making one on money, I should be including those prices. So they told me one type of ticket was $25 each, the other one was 18, and then they made a total amount of money here, 5,424. So this is now going to be $25 for every evening ticket, so 25E, plus $18 for every matinee ticket, so 18M, and that should be equal to the 5,424. Okay, so now we are asked to either solve by graphing, substitution, or elimination. I'm only going to choose one of these, and it does say that a grid is provided if you want to use the graphing method. I'm going to choose not to use the graphing method here. I'm going to choose to actually use, I think, substitution, because these numbers are a little big And I don't know if I want to multiply everything here by that big of a number to do the elimination method. So I'm going to write these out. E plus M equals 250. And then I also have 25. E plus 18M is 5424. Kind of looks like a Z, but that's a 2, I promise. I'll fix it up so it doesn't look that terrible. I'm going to use this equation right here, and I'm actually just going to isolate one of these variables. I'm going to solve for one of these. So I'll use E. I'll solve for E. That means I'm going to subtract M from both sides, and I'll have E is equal to 250 minus M. This now means I'm going to find wherever there's an E in my other equation and plug the expression here in instead. So I am going to need a calculator to do some of this. I know you get to use a calculator on your test, so please make good use of that. This is now going to become 25 times 250 minus M, and then plus 18M equals 5, 4, 2, 4. Okay, so let's multiply 25 times 250. This is 6250, and then 25 times negative M makes negative 25M plus 18M equals 5, 4, 2, 4. I'm going to combine my negative 25 and my positive 18. That's going to give me negative 7 or minus 7M. So 6250 just comes down, minus 7M is equal to 5, 4, 2, 4. Let's take this here, subtract 6250 from both sides. That leaves us with negative 7M. Always be careful of your signs, make sure that those come with. And then 5, 4, 2, 4 minus 6, 5, 6, 2, 5, 0 is negative 826. So we have one last step, which is to divide both sides by negative 7. Well, not one last step, but this is going to help us solve for M. One step in this equation, then we have another step to actually solve for our other variable. So if we take negative 826 and divide it by negative 7, we are going to get that M is equal to 118. So I defined M as the number of matinee tickets, which means they sold 118 matinee tickets. Now the nice thing is, when I bring this back up here, I can pretty easily plug it into this equation and solve to find the number of evening tickets, because it's already solved for evening. So I can say E is 250 minus now 118, and 250 minus 118 is 132, so I can say that evening is 132. Now, so they're asking what is the solution and what does it represent? I have two different pieces here, so I'm going to put a box around each of them just so that it's easy to see them. So what is the solution and what does it represent? So I can say, I'm going to write this as a sentence, which will kind of answer both questions. It's the number of tickets, so I can say they sold 132 evening tickets and 118 matinee tickets. And that both demonstrates what it represents, being the number of tickets, and also what the solution is, the actual amount of tickets. And that actually finishes up the back side of this page, which means we only have a couple questions left, and that's going to be our last page to work through together. So here we have questions 5 and 6, although they're a little longer. So let's actually go through these pieces here. We want to write our own system of equations for number 5. We're going to do 3 different ones here, and it does say explain in words why each one will have the required number of solutions. So let's actually talk about that first. I'm going to talk about what I'm writing for each of these. Now, if it has one solution, this means it's going to have different slopes. Any two lines or equations of lines that have different slopes will always cross and always have one solution. So these are going to be different slopes. That means my other ones will have the same slopes. So let's write something here first. Maybe I can say x plus y, or x plus 2y is equal to 5. Sure. We'll say x plus 2y is equal to 5. And then we can literally just give it different slopes. So we can say 2x plus 1y and make it equal to anything we want. It doesn't have to be a nice, neat equation in order to have different slopes. Now you'll notice I'm writing these both in standard form. Maybe I'll just put like 4 here. I could write these both in slope-intercept form. And if I did that, it would look like this. I would end up with y equals -1 over 2x plus 5 over 2, or 2.5. And if this one was in slope-intercept form, I would have y equals -2x plus 4. So you can see from here that they have those different slopes, -1/2 and then -2. The way we can kind of see it here is by looking at what is the coefficients on our x and on our y. And since those are kind of opposites here, we know they're not really going to be the same. But I'll show you a better example of that when I talk about no solution. So something with no solution would have to have the same slope, but a different y-intercept. So I might actually write these ones in slope-intercept form just to start with. Maybe I'll say like y equals 2x plus 1. And then here I would say like y, I have to use 2x since that was my slope in the other one, but this could be like plus 7. So I have same slopes, 2 and 2, but I have different intercepts of +1 and +7. Now, if I put these in standard form, you would see that they kind of look the same. It would look like 2x, sorry, -2x plus y equals 1, and -2x plus y equals 7. So when you look here, you can see that maybe a little more what I mean of how on our previous one, the coefficients were a little bit different from each other. Like x was 1 and 2, and then y was then 2 and 1. But here I have the same coefficients, so if I did elimination, they would all kind of cancel each other out. And then now infinitely many solutions is a little bit different. These ones would have same slope and the same y-intercept. So same slope, same intercept. And it would be a little too easy if I just wrote this all in slope-intercept form. So I'll kind of give you an example of what it looks like in standard form, because those ones are sometimes a little harder to see. If I use like 2x plus 3y equals 5, any multiple of this, so if I multiply this entire equation by something, that would also be the exact same line. It would end up with the same slope and the same intercept. And then I'll show you guys what the actual slope-intercept form of that would be. So let's just multiply everything here by 2. So we can say this is 4x plus 6y equals 10. And then we can just say for our slope-intercept form, these would both turn into y equals negative 2 over 3x plus 5 over 3. Not nice for my intercepts or anything like that, but they both become the same thing. I'm going to actually make these lines a little separate and show they both become that same thing here. So this would be my example for infinitely many solutions. They would both lie on top of each other. And that leaves us with one question left, but there are a couple different parts to it. So let's read through this word problem and then set up our equations and stuff, because it sounds like we're gonna have to write our own equations. Okay, so a new video streaming and renting company called Webflix claims it's better than its competitors. They charge $3 a month plus $1.25 per rental of new movie releases. A close competitor refutes the claim of Webflix. Refutes just means they disagree, and they think that it's wrong. They refute the claim and state that they are actually better than its competitors. So this new streaming service, Zulu, charges $4 a month plus $1 per rental of new movie releases. So let's write some I don't know if we rent 7 movies. I'm getting ahead of myself because writing equations, that's for the next part. So let's do Webflix in red, and we'll do Zulu in blue. So Webflix, if we want 7 movies, that would be $3 plus $1.25 per rental, so 1.25 for each movie that we're renting. I'm gonna do this on my calculator here just to make sure I don't make a mistake. 1.25 times 7, that's $8.75 plus the $3 is gonna make it $11.75. So $11.75. And then Zulu, they said they were $4 a month, so 4, and then they were $1 per movie rental. So sorry, I should write this maybe as dollars and cents, since that's what I did with the last one. $4 plus $1 per rental. Now I know 1 times 7 is just 7, and then we can add 4 to that. So 7, 8, 9, 10, 11. This is just $11 flat. 11.00, and then we can say Zulu is cheaper. But this is only if we rent 7 movies. So Zulu is cheaper if you rent 7 movies. Okay. So now let's write a system of equations based on X number of movie rentals. We can actually pretty much do that based on what we have here. So we can say the cost will maybe be Y, because they're saying X movie rentals, so we'll say the total costs, that'll be our Y variable. So the cost for Webflix, that was that $11.75 originally, but we're going to use this setup of the 3 plus 125 times 7, but instead of 7 movies, we're renting X movies. So this is 3 plus 1.25x. And then for Zulu, same idea. The cost is going to be 4 plus 1x. That's a system of equations. I have 2 separate equations here. So this could be considered my system. And then now they want to know how many movie rentals would it take for them to cost the same. So that means I want the Y values to be equal. Or really, it's just like how many movies, yeah, makes the cost the same. I want the Y values to be equal, and the X values to be equal at the same time. So really, this is asking you to solve the system. So let's actually solve this. Since both of these are kind of written in slope-intercept form, just based on their cost, since the cost is Y, we're going to actually use substitution. I think substitution is a little easier here. So I'll just write both of these in black, I think, first. So Y equals 3 plus 1.25x, and Y equals 3 plus 1, or 4 plus 1, sorry. 4 plus 1x. So showing in red, what I'm going to do here, for this y, I'm going to say it's equal to this here. We're going to plug that in for this y portion on the other side. So what that creates is now 3 plus 1.25x equals 4 plus 1x. Let's subtract that 1x from both sides. So 1.25 minus 1 is 0.25x. And then, let's zoom in here so you can see my work a little better. Let's subtract this 3 from both sides so that I'm starting to get x by itself. 0.25 times x. 4 minus 3 is 1. Last step here is to divide by 0.25 on both sides. And plug that into your calculator, and you'll get that x is equal to 4. Now, this is the number of movies, but I also want to find the cost. So if x is 4, one of my original equations I had was y equals 4 plus 1x. So y is equal to 4 plus 1 times 4. So y is going to be equal to 8. So what this means is that for movies, this x was movies, and y is 8 because that's going to be our cost. So 4 movies, $8. That's when they would cost the same. Now make an argument on which streaming service is the better cost. I would say I'm going to make my answer depend. I am going to say Webflix is better if I believe this one is better since it had the cheaper um, monthly fee. Webflix is better if if since it's cheaper monthly but more expensive per movie, it's gonna be better if you rent less than 4 movies. A month. Then we can say Zulu is better if you rent more than 4 movies a month. And then we can say both are, we'll say both are good. Oh, we'll say both are the same cost if you rent exactly 4 movies a month or 4 movies. So both are the same cost if you rent exactly 4 movies. Webflix is better if you rent less than 4 movies, and Zulu is better if you rent more than 4 movies. Somehow your your answer should be based kind of around that. You could make either um, you could make either argument because maybe someone just likes to stream stuff and they don't like to rent brand new release movies, or maybe you want to rent a bunch of the newest movies. So whichever argument is fine. I just wanted to include all aspects in my description. So that was our last page. There's nothing else. If I try to flip my page here. So hopefully my explanations helped. And yeah, good luck on your test. And trust yourself to know more than you think you do. My mantra is always to never second guess, but always double check. So double checking your work is fine, but don't second guess yourself. Go with your gut on how you think you would solve. So best of luck on your test, and uh, yeah, thank you for joining me for this video, the review for the Unit 2 test number 2.